Hello, my dear students of third prep. Today we are going to have a new lesson, which is the algebraic fractional functions, how to find its domain, and how to equalize them. Let us start our new lesson today. Algebraic fractional functions and its domain. First of all, if f of x equals x to the power of 2 plus 2 and g of x equals x plus 3, these are two algebraic functions. Now, if I want you to find n of x, where n of x is f of x over g of x, which is x to the power of 2 plus 2 over x plus 3. As it became a fraction, so we can say that n is called the algebraic fractional function. So what is algebraic fractional function? It is a fraction consisting of two functions divided by each other. So if you have f of x equal x plus 2, g of x equals x minus 2, then n of x, which is f of x over g of x, will be x plus 2 over x minus 2. If I want to find the domain of this algebraic fractional function, what's the meaning of the domain? Meaning of the domain is the values of x which makes this fraction correct. So this fraction will be correct if and only if the values of x are any number except 2. Why except 2? Because when I substitute for the value of x as 2, you are going to find that the denominator will be 2 minus 2 gives 0. And when you divide 2 plus 2, which is 4, divided by 0, it will give a math error. So we cannot divide any number by 0. So in this case, the domain of this function will be R, which is the set of zeros, minus set of zeros of the denominator, which is set of zeros of the function g. So take x minus 2 and say that it is equal to 0, equalize it by 0, so x equals 2. In this case, we can say that the domain of the function will be r except 2, or r minus 2. Then let us have some examples on finding the domain. If n of x equals x to the power of 2 plus 2 over x squared minus 4, find the domain of n of x. The domain, it means that the values of x which never make any problems. And the problem will appear in the denominator. So to find the set of zeros, we are going to find that the set of zeros is all the set of real numbers except set of zeros of the denominator. So try to find the set of zeros of the denominator, which is x to the power of 2 minus 4 equals 0. In this case, we can say that x to the power of 2 equals 4. By taking square root for both sides, you are going to obtain a result as x equals positive or negative 2. In this case, we can say that domain equals r minus set of positive or negative 2. Another example, if n of x equals x plus 5 over x squared minus 6x plus 5, find the domain of n of x. Yes, to find the domain, you are going to find the set of zeros of what? Of the denominator. So we are going to find x squared minus 6x plus 5 equals 0. Looking carefully, yes, you are going to factorize x and x. What about 5? It is only 1 by 5. What about the last term sign? It is positive. So both terms are with the same sign according to the sign of the middle term, which is negative. So you are going to obtain two brackets as x minus 5 times x minus 1 equals 0. two brackets multiplied by each other equals 0. So either the first bracket, which is x minus 5 equals 0, or the other bracket, which is x minus 1 equals 0. In this case, we can find the value of x as 5 or the value of x as 1. Now you have two values for x, which are 5 and 1. Then what about the domain of such an algebraic fractional function? Yes, the domain will be all the set of real numbers except 1 and 5. So the domain equals r minus the set of 1 and 5. Another example, if n of x equals x to the power of 2 minus 3 over x to the power of 2 plus 5x, find the domain of n of x. Yes, that's correct. To find the domain, we are going to find the set of zeros of the denominator. So what about the denominator? It is x to the power of 2 plus 5x. Equalize it by 0, so it is equal to 0. Then, can you factorize now? Of course, yes. But how? How can you factorize such a statement? Yes, by taking x as a common factor. So by taking x as a common factor, to find the terms inside the bracket, you are going to divide x to the power of 2 divided the common factor, which is x, gives x. Then divide 5x by the common factor, so 5x divided x gives 5. So the bracket will be x plus 5. Then you obtained x multiplied by x plus 5 equals 0. Two terms multiplied by each other equals 0. So either the first term, which is x equals 0, or the other term, which is x plus 5 equals 0. Now you have obtained value of x as 0. What about the value of the other x? Yes, by subtracting both sides by 5. So x equals negative 5. Now you have two values for x, negative 5 and 0. So what about the domain? All the set of real numbers except 0 and negative 5. So we can say that domain equals r minus 0 and negative 5. Let us have another example. If n1x equals f1x over g1x and n2x equals f2x over g2 of x. To find the common domain of n1 and n2, if you have two algebraic fractional functions, and I want you to find the common domain between these two algebraic fractional functions. First of all, you are going to divide this problem into two parts. The first part is n1x. Try to find its domain. So the domain number 1, which is for the set n1, it is r minus set of zeros of g1x. Then what about the domain number 2? It is for the algebraic fractional function n2, which is r minus the set of zeros of g2 of x. And then to find the common domain between them, it is r minus, that's correct, z of g1x union z g2 of x. It means r except the set of zeros of g1x union the set of zeros of g2 of x. Let us have an example. If n1x equals x minus 1 over x squared plus 3x plus 2, and n2x equals x over x squared minus x minus 6. Find the common domain of n1 and n2. At the very beginning, we are going to divide this problem into two separate problems. The first part is to find the domain of n1x. Yes, it is r minus set of zeros of the denominator. So try to find the denominator, x to the power of 2 plus 3x plus 2 equals 0. Try to find its set of zeros. Yes, you are going to factorize x and x. What about 2? It is only 1 times 2. Then the last term is a positive sign, so the two terms are like each other. Both are either positive or both are negative. You are going to choose the positive sign as the middle term is with a positive sign. So the two brackets will be x plus 2, x plus 1 equals 0. Two brackets multiplied by each other equals 0. So either x plus 2 equals 0 or x plus 1 equals 0. Now can you find the values of x? Of course, yes. X equals negative 2 or x equals negative 1. In this case, we can say that z1 of n1 is d1. We are going to find d1. It is r minus negative 2 and negative 1. This is the first part of the problem. What about the other part? Yes, to find the domain of n2, which is all the set of real numbers except the set of zeros of the denominator. So try to find the denominator, which is x squared minus x minus 6 equals 0. Try to make the factorization, x and x. What about 6? It is 1 by 6 or 2 by 3. You are going to choose which group? 2 by 3. Why? Because the last term is negative, so the difference between them will be 1 as the middle term. As the last term is negative, so one of the brackets positive, the other is negative. The greater number is with a negative sign and the other one is of a positive sign. So the two brackets will be x minus 3 multiplied by x plus 2 equals 0. As two brackets multiplied by each other equals 0, so either x minus 3 equals 0 or x plus 2 equals 0. Then what about the value of x? X will be 3 or x will be negative 2. In this case, we can say that domain number 2 is the set of real numbers except 3 and negative 2. So d2 equals r minus negative 2 and 3. What about the common domain? The common domain is r minus the union of the two set of zeros. So it is r minus 3, negative 2, and negative 1. Let us have another example. n1x, find the common domain of n1x equals x minus 1 over x squared minus 8x plus 12. n2 equals x over x to the power of 2 minus 4. And n3 of x equals x plus 2 over x squared plus 4. At the very beginning, you are going to ask, can we find common domain for 3 algebraic fractional functions? Of course, yes. How? By the same way, you are going to find the set of zeros for each denominator and find the domain of it. And finally, the common domain will be R except the set of zeros of N1, G1, N1, N2, and N3. How can you find such a problem? At the very beginning, divide this problem into 3 parts. The first part is N1. To find its domain, you are going to find that x squared minus 8x plus 12 equals 0. Of course, yes, you are going to factorize x and x. What about 12? It's 1 by 12, 2 by 6, 3 by 4. Which group are you going to choose? That's correct, 2 by 6. Why? As their sum will be 8. What about the signs of the two brackets? The last term is a positive sign, so they are both like each other. According to the middle term, it is negative, so the two brackets will be with a negative sign. Then the two brackets will be x minus 6 multiplied by x minus 2 equals 0. Then when two terms multiplied by each other equal 0, so either x minus 6 equals 0 or x minus 2 equals 0. Then x equals 6 and x equals 2. So we can say that the first domain D1 equals r minus 6 and 2. Then let us see what about n2x. Its denominator is x squared minus 4. So equalize it by 0. X squared minus 4 equals 0. Here you can make a factorization, or you can write x plus 2, x minus 2, as it is a difference between two squares. Or x squared equals 4 and take the square root for both sides. Two terms multiplied by each other equals 0. Either the first one, x plus 2 equals 0, or the second one, x minus 2 equals 0. So we can say that x equals negative 2 or x equals 2. Then we can say that domain number 2 equals r except negative 2 and 2. Then what about n3? Yes, try to find d3. You are going to take its domain. Yes, its denominator is x to the power of 2 plus 4. Equalize it by 0. So x squared plus 4 equals 0. Then x squared equals negative 4. Try to find the square root for both sides. So x equals positive negative square root negative 4, which is refused. Why? Because we cannot find a square root for a negative number. So in this case, we can say that the domain number 3 will be all the set of real numbers. No values for x give a 0 denominator. So what about the common domain of the three algebraic fractional functions? The common domain will be R except the set of zeros of all the three algebraic fractional functions of the denominator, of course. So it is R except 6, 2, negative 2. Then let us see what about equality of algebraic fractional functions. First of all, we are going to talk about reducing algebraic fractional functions. If you have an algebraic fractional function like n of x equals x plus 2 over x squared plus 3x plus 2. First of all, when you look carefully to the denominator, you are going to notice that you can make factorization. So we can say that n of x equals x plus 2 over, what about the two brackets, x plus 2, x plus 1. What are you going to notice? Can you find the domain? Yes, of course. And you are going also to notice that x plus 2 is repeated once in the numerator, another time in the denominator. Then you can make a reducing process. So we can say that the domain equals all the set of real numbers except the set of zeros of the denominator, which is negative 1 and negative 2. And then reducing x plus 2 by x plus 2 to obtain a result as nx equals 1 over x plus 1. This is called reduction of the algebraic fractional functions. If you have the same term in the numerator and the denominator, you can reduce them with each other. Let us see another example. If nx equals x to the power of 3 plus x to the power of 2 minus 6x over x to the power of 4 minus 13 x to the power of 2 plus 36, find n of x in its simplest form and deduce domain of n. I want you to make the simplification process and then find the domain. First of all, as n of x equals x power 3 plus x power 2 minus 6x over x to the power of 4 minus 13 x to the power of 2 plus 36, you are going to notice that you can make factorization. For which part? The numerator or the denominator? For both of them. How? When you look carefully to the numerator, you are going to notice that you can take x as a common factor. So it will be x brackets by dividing, of course, x power 3 divided x gives x power 2 plus x power 2 divided x gives x, then minus 6x divided x equals 6. When you look carefully at the denominator, it also can be factorized. How? X to the power of 4 will be x to the power of 2, x to the power of 2. What about 36? Either 1 by 36, 2 by 18, 3 by 12, 4 by 9. And we are going to choose 4 by 9 because their sum will be 13 as the middle term. And the last term is positive, so both brackets will be like each other according to the sign of the middle term, which is negative. So the two brackets will be x to the power of 2 minus 4, x to the power of 2 minus 9. When you look carefully, you are going to notice that you can make another factorization. What about x squared? In the numerator, it will be x and x. What about 6? Either 1 by 6 or 2 by 3. You are going to choose what? 2 by 3, as the difference between them gives 1, which is the middle term. So the numerator will be x brackets x plus 3, x minus 2 over. What about the denominator? Both brackets are difference between two squares. What about x power 2? X and x. What about 4? It is 2 times 2. And the last term is negative, so one is positive, the other is negative. So you obtain x minus 2, x plus 2. What about x power 2 minus 9? Difference between two squares. So the two brackets will be x minus 3, x plus 3. At the very beginning, before reducing anything, you must find the domain first. You are going to find the domain before reducing any like terms. Please take good care of this. Try to find always the domain before reduction. Then the domain will be r except 2, negative 2, 3, and negative 3. Then reducing like terms, which are x plus 3 with x plus 3, x minus 2 with x minus 2, to obtain a result as nx equals x over x plus 2, x minus 3. Now, what about the equality of two algebraic fractions? What's the meaning of equality of two algebraic fractions? If you have two algebraic fractions and they are equal, how can we say that they are equal? Let us see. Find n1 and n2 in simplest form and find their domain. If you have n1x equals x plus 3 over x squared minus 9 and n2x equals 2 over 2x minus 6. Here in this case, you are going also to divide the problem into two parts. The first part is n1, the other part is n2. Let us start by n1x equals x plus 3 over x squared minus 9. First of all, you are going to notice that n1x equals x plus 3 over x squared minus 9. X squared minus 9 can be factorized. So it is x plus 3 over difference between two squares. So it is x plus 3, x minus 3. Try first before reduction. Try to find the domain. So the domain will be r minus 3 and negative 3. And by reducing like terms x plus 3 with x plus 3, you are going to obtain a result as 1 over x minus 3. What about n2x? Yes, it is 2 over 2x minus 6. Then you can factorize the denominator. How? By taking 2 as a common factor. So it is 2 over 2 brackets by dividing 2x divided 2 gives x. Negative 6 divided 2 gives negative 3. So it is 2 brackets x minus 3. Also try to find the domain, which is r minus 3. And reducing 2 with 2 to obtain a result as 1 over x minus 3. First of all, you are going to notice that the two algebraic fractions after being reduced are the same. 1 over x minus 3, 1 over x minus 3. So when you reduce them, obtain the same result. But what about their domains? D1 is different than D2. So D1 is not equal D2. When you have a difference, either in the reduction or in the domain, we are going to say that these two algebraic fractional functions are not equal. So, the very important method to prove that these two algebraic fractions are equal or not, then their reduction must be the same, their domains must be the same. If one of them is not found, so they are not equal algebraic fractional functions. Let us have another example. Find n1 and n2 in simplest form and find their domain. n1x equals 2x over 2x plus 4. And n2x equals x squared plus 2x over x squared plus 4x plus 4. First of all, n1x equals 2x over 2x plus 4. Then by taking 2 as a common factor from the denominator, it will be 2x over 2 as a common factor, and then by dividing, so it is brackets x plus 2. Then it is after reduction will be x over x plus 2. And what about the domain? Domain number 1 will be r except negative 2. What about n2x? It is x squared plus 2x over x squared plus 4x plus 4. Both numerator and denominator can be factorized. The first is the numerator. How can you factorize it? That's correct, by taking x as a common factor. So x brackets x plus 2 over the denominator. To factorize it, it is x and x. What about 4? Either 1 by 4 or 2 by 2. Of course, you are going to choose 2 by 2 as their sum gives 4. So the two brackets will be x plus 2, x plus 2. By reducing, so it will be x over x plus 2. What about domain number 2? It is r except negative 2. Did you notice? n1x after reduction is x over x plus 2. And n2 after reduction is x over x plus 2. They are the same. What about their domains? D1 is r except negative 2. D2 is the same, r except negative 2. As the reduction equal and D1 equals D2, so we can say that N1 equals N2. By the end of this example, we have reached the end of our lesson today. Thank you for good listening. I wish all of you the best of luck. Goodbye.